Okay, guys. Good day. Today we talk dilaka the acids and bases. Okay. So more topic in rona of acids and bases. We have two theories, which is the Arrhenius and Lori Bronsted. Okay. Now, what do these two theories say before we can get deep into the topic? So we have acids and bases. Okay, as topic of the day. Then the first one we are going to look at is the Arrhenius acid and Arrhenius base. Okay. Now we need to get into a deeper understanding with Arrhenius when he says okay an acid. For example, when he was defining the acid, for example, he said an acid is a substance that produces is a substance that produces hydronium ions in water. Okay, H3O plus hydronium ions in water. Others will say plus. Okay, so produces hydronium ions in water, or others they said in aqueous solution. Okay, now looking at this, you can clearly see that the Arrhenius acid is limited to a certain environment. Okay, it is limited to happen in the presence of water. Now the base will be a substance that produce hydroxide ion in water. Okay, so now this is Arrhenius base. Either the acid produces hydronium ion in water and the base produces OH, hydroxide ion in water. Okay. Um, so imagine if there was not water present. So according to the theory of Arrhenius, an acid or a base does not exist outside the scope of an aqueous solution. Okay. Now let us look at Lori and Bronsted. So Lori Bronsted. These two they made it a little bit easier to remember and at the same time more effective. Okay, they say an acid is a proton donor. Okay, when you talk about a proton donor, we talk about H plus ion. Okay, and the base is a proton acceptor. And the main reason I'm saying this theory was more efficient is because not all compounds include OH, as Arrhenius said. Okay, no, not all bases have the hydroxide substance in it. So hence Lori Bronsted becomes more efficient. And another thing, it is not limited to an environment. You can see that it doesn't say it happens in water. Okay, When you say something happens in water, you are basically limiting us to that environment. Okay, so now since you know what an acid is, what a base is, we are going to deal with some strange equations here, some solutions that we need to produce, for example, titration. Okay, so but it's good. I'm going to get you through it. Okay, no problem. Now, before I go to calculations, I want you to understand a few terminologies. For example, we need to know what is a strong acid, what is a strong base, what is a weak acid, what is a weak base. Okay, now when we talk about a strong acid, I'll give you an example of it now. When you talk about a strong acid, an example is hydrochloric acid. Okay, we say a strong. Okay, let me write this. We say a strong acid is the one that completely ionizes in water. We call that a strong acid. For example, when we look at a hydrochloric acid, when it gets into water, it will split into H plus ion and Cl minus. So it completely ionizes, it completely forms ions, okay, when it gets to water. So we can call this a strong acid. Now, what is a weak acid? Okay, now when we talk about a weak acid, when we talk about a weak acid, we are talking about an acid that partially partially ionizes in water. In water. Okay. So the same definitions are true when we come to a base. When you talk about a base, a strong base is the one that completely ionizes in water, and a weak base is the one that partially ionizes in water. Other textbooks they use the term dissociates. Okay, now it's fine. I believe we can pass through this term. Okay, so some terminologies we are going to learn through the lesson, like what do we call a substance that can act as either a base or an acid, or what is a solution of a well-known concentration. So we'll get there. Okay, so now we will get a good example. I will show you just now. I'll show you just now. This is the example that we are going to use, okay, to practice our topics. All right. So they say in a grade 12 class wants to determine the percentage of ethanoic acid. Okay. So in a certain bottle of vinegar. Okay. So guys, remember ethanoic acid is present inside vinegar, but vinegar it's not doesn't necessarily mean it is ethanoic acid. Okay, so it says they titrate a sample taken from the bottle of vinegar with a standard solution of sodium hydroxide. Okay, now when we talk about a standard solution, 7.3, we will explain. Okay, now we are also given the equation as follows. Now, is our equation balanced? Well, we can check. Well, this and this are essentially the same thing except for Na. So Na switched position with H, hence water. Okay. Now, every time when when you want to recognize an acid and base reaction, you will see that when you add an acid plus a base, you will have a salt plus water. Okay. When you take an acid and a base, you will have a salt plus water. When you say salt, it doesn't necessarily specify table salt, which is sodium chloride. It can be salt of many different forms. Okay. Now define an acid in terms of Arrhenius theory. We just explained Arrhenius theory. An acid is a substance that produces hydronium ions in water. That is Arrhenius theory. Okay. Give a reason why ethanoic acid is classified as a weak acid. So now, okay, I rubbed. Before we came to this paper, I explained what do we mean about a strong acid, what do we mean about a weak acid. So when we talk about a strong acid, we talk about what? The acid that completely ionizes in water. But when we talk about a weak acid, is the one that partially ionizes in water. So this one you will see because it partially ionizes in water. That's why it is a weak acid. Now, what is a standard solution? Okay, when we talk about a standard solution, uh, we are talking about a solution. We talk about a solution with a well known concentration. Is an O concentration. Okay, now that is the definition of standard solution. A solution with a well-known concentration. Okay, now let us prove this. They say a standard solution here, a standard solution of sodium hydroxide. Now let us go to this statement here. You can see they gave us volume and they also give us concentration of what? Sodium hydroxide solution. So it is true, it's a standard solution because we know what? The concentration of what? Sodium hydroxide. Okay, now 7.4, they say write down, we are here, write down the names of two items of apparatus, okay, needed to measure accurate volumes of the acid and the base in this titration. Okay, we will need a pipette. Yes, we will need a pipette. I hope this is the correct spelling. Okay, guys, you know when we go to physics and mathematics, we don't necessarily care about the spelling, but it's very important that we know. You can also use a burette Okay, so a pipette and a burette. Okay, now 7.5, that's where we need to focus. Okay, so it is found that 40 milliliters of 0.5 mole per cubic decimeter sodium hydroxide solution is needed to neutralize a 20 milliliter of vinegar. Okay, so now firstly you need to check what is it that you have. Okay, that's first things first. What is it that you have? What is it that you do not have? So you want the pH of sodium hydroxide. So what is the formula of pH? Negative log, okay, the concentration of hydronium ions. Now let us focus what is given here. So we have the concentration of sodium hydroxide, okay. So since we have the concentration of sodium hydroxide, can you use the concentration of sodium hydroxide to get the concentration of? You definitely can, okay. So now what we're gonna need to do, we're gonna use the formula of Kw, okay. So Kw, I think they also call it a water constant. So Kw is equals to the concentration of H3O plus also multiplied by the concentration of OH negative. Okay. Now the value of Kw is known, which is 1 multiplied by 10 exponent negative 14, which is equals to concentration of hydronium is unknown. So it's H3O plus. Then the concentration of OH, it is given here. Here. Okay, let me use a different pen so that we can see when I highlight. It's given here as 0.5. Okay, below that red mark. So you go to the paper, you substitute 0.5. Okay, so what you're gonna do now, you're gonna divide both sides by 0.5. Okay, divide by 0.5. Okay, now 0.5 is the same as dividing by half, so we'll have 2 times 10 negative 14 is equals to the concentration of what? H3O plus. Okay, now pH is equals to minus log the concentration of what? H3O plus. Okay, now which is equals to minus log the concentration of what? That one, which is 2 times 10 exponent minus 40. Okay, so the value that you get is 13.7 without units. So this is mainly because pH really doesn't have units. Okay, now let's go back to the paper and see. So when you come to the paper, 7.5.2, okay, they want percentage of ethanoic acid, okay. They want percentage of what? Ethanoic acid by mass present in vinegar. Okay, so no problem. Now let us look at what we have. We have the concentration here of what? Of NaOH. Okay. We also have the volume here of NaOH, but that volume is in milliliter. Okay, we want to keep it in cubic decimeter, like the concentration. Cubic decimeter is equivalent to 1 liter. So to move from milliliters to liter, you divide by what? 1,000. So we're gonna have that 40 divided by 1,000, which should be 123. So 0.04. Okay. Now, since we have established that, what we are going to do is to have we are at, I think, 7.5.2 if not mistaken. So now we will say n, number of moles of what? Number of moles of NaOH, sodium hydroxide, is equals to what? C, concentration multiplied by the volume. What is concentration? It was 0.5, volume 0.04, the one we just turned divided by 1,000. Okay. Now, when you multiply these two, you will get 0.02. And we're looking for what? N, which is number of moles. Okay. The unit for moles is mole. Are you satisfied? Now, going to the balanced equation, the ratio of the base to the acid is 1 is to 1. Okay. So since the ratio is 1 is to 1, now that means the number of moles of what? NaOH is the same as a number of moles of what? CH3 COOH, which is equals to 0.02 mole. Okay, now fellows, we have what we call number of moles of our acid. Okay, so what we are going to do, we are going to look for the mass. Okay, remember this is called ethanoic acid. So we have number of moles of what? Ethanoic acid, and we want the part of ethanoic acid inside what? A vinegar. Okay, so mass is equals to number of moles multiplied by molar mass, the bigger M. So number of mole is 0.2, 0.02, I'm sorry. Molar mass is got on the periodic table. What you do, you go to the periodic table, look for the mass of 12 of carbon, 12 mass of H, which is 1. Now it will be 1 times 3 because there's a 3 down there. Then add 12 mass of oxygen, 16 plus 16 plus 12, and overall you will get 60. Okay, so if you multiply everything together, you get 1.2 grams because it's mass. Okay, now after getting 1.2 grams, they said assume 1 milliliter of vinegar equals to 1 grams. So you are given 20 milliliter of what? Vinegar. So effectively they gave you 20 grams. Okay, effectively they give you 20 grams. Now you go back to the paper. Now since you have 20 grams, so you want a percentage of what? Vinegar, which is equals to 1.2 of of ethanoic acid, which is this one, inside what? Vinegar, which is 20. Then you multiply by what? 100. Okay, so you will get around 6%. So 6% of the vinegar is ethanoic acid. Okay, so looking at the final question 7.6, they say the sodium ethanoate. Okay, sodium ethanoate formed during the above neutralization reaction undergoes hydrolysis, okay, to form an alkaline solution. Okay, write down an equation for this hydrolysis. So, guys, this topic of hydrolysis we're gonna teach during a later stage in my lessons. So, for now, I'd like to skip the lesson. I'll just give you the answer so that we don't leave these questions unattended. Okay, so now when we have this in water, you are going to have your normal substance, which is CH3COOH. Now that it's in water, that sodium is no longer there. Okay, plus H2O is a liquid. Okay, so now this means it's in pure water. Then now you are going to have your CH3COOH, okay, then plus your hydro oxide. Now keep in mind what happened here. So water donated hydrogen to this guy and became what? OH. Okay, so there are instances where water gains and it becomes H3O plus, but in this case, water decided to give up a precious hydrogen atom. And we have a name for substances like this. We call them an ampholyte. Okay, I'm sorry, it's called an ampholyte. Ampholyte with A at the beginning. Okay, so yes, like ampholyte. Now, ampholyte is a substance that can act as either a base or an acid. Okay, as either a base or an acid. That is the ampholyte. Okay, now let us look at another paper. Okay, let us look at another paper. Um, so here we have question 7 again. They say learners prepare a solution of known concentration by dissolving 2 grams of pure sodium hydroxide crystals. Okay, sodium hydroxide achievable file is NaOH in water in a 250 cubic centimeter volumetric flask. Okay, so those are one of the apparatus that you use. Write down the term underlined in a phrase. Okay, the mean for you, you must, this is a definition, write down the term, what is meant. So it's a standard solution. Okay, the term is standard solution. Calculate the concentration of sodium hydroxide. Now, how do you go about it? I mean, to calculate the concentration shouldn't be that hard. What do we have? We have mass, we have volume. So to calculate concentration with the formula that has mass, you need what? Molar mass multiplied by the volume. Okay? Now, so since concentration is equals to mass over molar mass times volume. So what is the mass? Mass it is given as 2 grams. Okay. So I'm going to turn this thing into decimeters. Okay. 1, 2, 3. It will be 0.25. So we have 2 grams. 2 grams divided by molar mass times 0.25. Now, what is a molar mass of sodium hydroxide? Now, sodium hydroxide, sodium, I think it's number 23 in the periodic table. Um, let's check. Okay, there we go. Can you see now? This is a key that show you relative atomic mass is shown on this position. So with sodium, there is the mass. It's sodium hydroxide. So it's sodium NaOH. So it's 23 plus 16 plus H. H is 1. Okay, there it is. So we'll have 23 plus 16 plus 1. Okay, so 24 plus 16 and 30. This will give me, if I'm not mistaken, 40. Okay, so now we have a 40 times 0.25. Okay. Um. Okay. Now we can have a calculator because I really don't know how much this will be without a calculator. So you do that. So I'm working it out on the screen so that you guys can actually see everything that I am doing. Okay. So let us see what we have. 2 divided by that. Okay. So I'm going to put that in a bracket. So you'll have 2 divided by 40 times 0.25. Then you close your brackets. So then equal sign. So now the answer is 0.2. So we have 0.2 mole per cubic decimeters. Okay. So now the question said calculate. Oops, it's question 7. Okay. Calculate the concentration. So concentration was successfully calculated. Now calculate the pH of the solution. So remember, this is sodium hydroxide, which is a base. So when you calculate pH, so since it's a base, it will be POH, which is equals to negative log the concentration of OH, then which is equals to negative log. Now that concentration is 0.2. Okay. Do we have such functions in our calculator? Yeah, I guess. Let's see if we can. So minus log, no, not that. I want to remove everything on my screen. Okay, there's no button for cancel, refresh or clear. Okay, so it's fine. That's fine. So we want yes, we want negative log uh, 0.2. Where's that log? Yes, but now there's supposed to be a negative there. Okay, guys, we know that there's supposed to be a negative. Okay, you can see I'm using a Madala calculator. So since the answer is 0.7, we are neglecting that negative because I also didn't put negative on my log. So we have 0.7 there. Okay, so the answer will be 0.7, then pH will be 14 minus 0.7, which will give me 13.3, which is basic. Anything greater than 7, we say it is very basic. Okay, now going back to other questions, now we are here. Okay, 8 marks. So now, if you want to try it, guys, please pause the video. You can try it yourself, then continue the video for the solution. Now calculate the initial concentration of the dilute acid. So this acid, it is used on this reaction. Then the pieces that remains, it's this one. Then they use it with this one to produce that. Okay. So if we can add what we have here and what we have here, we can get HCl that we had in the beginning. Okay, so let us erase and solve for the problem. So what we did on this question was to calculate for concentration. Okay, the ones that I ran. Okay, concentration of the sodium hydroxide. So now, if we want number of moles of sodium hydroxide, we will say which is equals to concentration multiplied by the volume. Okay, so now the concentration was found to be 0.2 by our previous calculations, multiplied by the volume which is given, and it's 0. Let me see again here 0.05, because 1 2 3 years 0.025, 0.025. Now 2 times that will be a 5. Okay, So we will have sorry 0.05 1 2 3. Is it 1 2 3 or is it 0. Let me check on my calculator before I give you a wrong solution. So 0.2, okay, remove 1 times 0 comma 0.25, 0.005. Okay, so there's another zero to be involved. Okay, so bear with me like this. Okay, now this unit is in mole because it's number of moles. But now when we go to the balanced equation, the ratio of hydrochloric acid is to sodium hydroxide is 1 is to 1 here. The ratio is 1 is to 1. So if we have number of moles of sodium hydroxide, so therefore we will have number of moles of what? Hydrochloric acid, which is equals to 0, 0.005 mole. Okay. So based on the balanced equation. Now, since this one is established, we go back again. Okay. We will seek number of moles of this. Now, what do we have? We have the mass. Okay. So you can find molar mass. And then finding molar mass, you can get number of moles. So number of moles of a let me wrap so don't need to here. So number of moles of calcium carbonate is equals to mass over molar mass, which is equals to the mass was given as 1.5 grams, 1.5 grams, yes, 1.5 grams, okay, over molar mass, which will be 100, then equals to, okay, you can calculate, so it will be 1.5, okay, so we have 1.5 divided by 100, which is equals to, there you go, okay, 0.015, which is equals to 0.015. Okay, so now having the number of moles of this, now I want to find the number of moles of hydrochloric acid. So what do we do? I go to the balanced equation. I check. Oh, so number of moles of hydrochloric acid is to this is 2 is to 1. So for them to react, you need 2 parts of hydrochloric acid. Okay. Now I will say number of moles of hydrochloric acid will be 2 times 0.015, which will be 0.03 mole. Okay, now effectively, what we can do, we can now add. Okay, so you can now add this and that. So bear in mind this, let me write with a different color. These have got two zeros uh, after a comma. This one has got 1 0. So that means number of moles of hydrochloric acid will be 0, comma 0, 3, this one, and a 5 after the 3. Okay, like that. Okay, so units are more. All right, now we go back to the question. Very important, guys. You need to find out that, okay, what did the question initially want? Okay, so the question says calculate the initial concentration of the dilute dead. Ne? So the dilute, they gave us the initial volume. So that volume you divide by 1000 will be 0, 1, 2, 3, comma 0, 5. Okay, so since you have the volume, you want the concentration, you will say C. Concentration of hydrochloric acid is equals to volume, is equals to number of moles over volume, which is equals to 0,035 divided by 0,05. Okay, now if you take a calculator, what will you have? Let's find out. Cancel. So we'll have a 0,035 divided by 0,05 equals to, the answer is 0.7. So now the answer will be 0.7 mole per cubic decimeters. Okay, so for today, guys, that's one of the problems we deal with. So keep on practicing, guys.